scientists may have found ancient galaxies that could rewrite what we know about the universe. A new study from the University of Missouri has revealed something surprising in deep space. By examining infrared images from NASA's powerful James Webb Space Telescope, JWST, researchers discovered 300 objects that shine much brighter than expected. Quote, "These strange objects might actually be galaxies from the very early universe," said Haojing Yan, an astronomy professor at Mizzou and co-author of the study. Quote, "If even a few turn out to be what we think, it could challenge, but finding and confirming objects in space takes time. Scientists what we believe about how galaxies first formed. Let's follow a careful, step-by-step process that combines high-tech tools, deep analysis, and a bit of cosmic detective work. To begin with, the team used two of JWST's special infrared cameras, the near-infrared camera and the mid-infrared instrument. These tools are designed to detect light from the farthest corners of space, which is key when studying the early universe. Why use infrared light? Because the farther away something is, the longer its light has been traveling toward us. As that light travels, it stretches and shifts into longer wavelengths, moving from visible light into infrared. Quote, "This effect is called redshift. The more redshifted the light, the farther away the galaxy is, and the closer it is to the beginning of the universe," Yan explained.
Of such a large object during the short time telescopes like ATLS have been searching the sky. Adding to the mystery, new data from the Very Large Telescope.
Next, the researchers used a technique known as the dropout method to help identify the distant galaxies. Quote, "This method looks for objects that appear in redder wavelengths but disappear in bluer ones," said Bangxing Tom, a PhD student working with Yan and the lead author of the study. Quote, "This pattern happens due to the Lyman break, which occurs when ultraviolet light is absorbed by hydrogen in space. As redshift increases, this feature moves to redder wavelengths." This method helped the team narrow down which of the bright objects could be from the early universe. After identifying possible early galaxies, the next step was to estimate just how far away and how old these objects might be. Ideally, this would be done using a technique called spectroscopy. This method spreads light into different wavelengths to reveal patterns that help scientists measure the redshift accurately. However, when full spectroscopic data isn't available, scientists can use something called spectral energy distribution fitting. This approach helped the team estimate not just redshifts, but also properties like the age and mass of the galaxy candidates. In the past, many experts believed that such bright objects couldn't be early galaxies. They thought they were something else that only looked similar. But based on their results, Sun and Yan think these objects are worth another look. Quote, "Even if only a few are truly early galaxies, it would be enough to force us to rethink current theories about how galaxies first formed," Yan said. Finally, the most reliable way to confirm the team's discovery is by using spectroscopy, the gold standard in astronomy. This method breaks the light from a galaxy into its individual wavelengths, much like a prism creates a rainbow, revealing details about what the galaxy is made of, how it formed, and how old it is. Quote, "So far we've confirmed that one of these objects is an early galaxy using spectroscopy," Sun said.